Bhai.
Yeah, Chairman.
So, done?
Deepak bhai, can we start? Yeah, good evening.
Just put the video on. Okay. So, good evening, friends, and welcome to Baroda Management Association Friday evening talk. And we are here with another excellent program, very informative, and we have one of the most knowledgeable, most eligible person who can deliver a talk on this subject, and that is Mr. Tanmay Mukherjee. He is basically a sweet Bengali person and having an excellent, brilliant student career, one of the brightest student throughout his career. He did his BTech from NIT Durgapur and MTech from IIT Kharagpur, and he is one of the most reputed CAD professional of the CAD domain, that is Computer Aided Engineering CAE. He has about 27 years of product development and virtual validation experience in various industries, including Volvo, General Motor, Chrysler, Caterpillar, L&T, and he's a global head for delivering CAE solutions from L&T. He was abroad for a number of times and in number of organizations, and he has been offered jobs in USA, but he decided to serve India, and that's how he is in Baroda. I can talk a lot about him. A very sweet person with my short interaction with him. One of the most meticulous and one of the brilliant person I ever come across. And I think that his presentation, his talk will say, and he is very down to earth. So the kind of stuff you will see out of his presentation will really help the engineer and the people who are not even from the engineering background. They will also understand that what all he want to say. So product design and development, Modi ji is talking a lot about making India and startup India and a lot of things, and we want a lot of products to be developed locally. So how those products are validated instead of before making a prototype model, and he will take us through the entire journey of the product development. So the common man, when they see that the mobile or car or TV or any product, washing machine, so they will know the kind of work that engineers are doing before the product comes into the market. Without taking much time, I think that I request Mr. Tanmay Mukherjee, and I'm really very much thankful to him for accepting our invitation to deliver a Friday evening talk. So over to faculty, Shri Tanmay Bhai Mukherjee. So, sir, all yours. Thank you.
Thank you, sir. And good evening, friends. Very nice, sir. Thank you very much for your over-exaggerated, introduction for me. I never knew that I am so brilliant and I have done so many things. But really, I first of all, great thanks to you for introducing me to such a beautiful organization and beautiful team and such a knowledgeable and senior people around. I'm so much honored, sir, right from my bottom of my heart. And I'll stick on with this, and I'll try to make sure that whatever contribution I can make to this particular organization to go to the next high. So with this, Deepak sir, and with everyone's permission, can I share my screen with all of you?
Yes, please go ahead. Thank you.
Please let me know if my screen is visible to everyone.
Yes, it is visible.
Okay, I'm putting that into Yeah.
Put it full screen. Yes.
Yeah.
Yeah. Excellent.
So, good evening one more time to everyone, and thanks for joining this call. And I'm really honored that I got a slot here in this particular forum to talk about whatever small work that we have been doing in L&T in whatever we have done so far in my past organization. And the heading itself talks about the particular subject that it's simulation powered product development. So I will first slowly talk through that what is a product and why people need new products in this market, the competition for introducing new product into the market, what are the different pain points to introduce the product quickly, fast, with good quality and low cost, and how simulation kind of a the computer aided engineering and CAD and CAE, how it will help the companies, or it is already helping the companies to bring the product into the market really quickly, and also without spending less money, with lot of accuracy, and continuously building on their innovation part. Okay, so with that particular background, this is the agenda for today. I have already spoke about. Now, my short introduction has already been given by Deepak sir. So, product. So as we know that we are all surrounded by variety of products, right? It be can be a tangible product like a physical goods, or a services, or some kind of a software. All whatever we have, those features, functions, and some of the uses and benefits, we call them as products. So it's a combination of both the things. It could be tangible, it could be intangible, but we are all used to the products. We are all surrounded by products. We use products on a daily basis. So that's a very short definition of product in a nutshell. And what does a great product create? Why customers want to create great products like this Apple? It's a great product. What it creates in the customer minds, that it creates a bond, a stickiness with the customer. And it also creates the value for the shareholders. It also creates a differentiator in the market, that this Apple is different from any other company, any other organization. Mercedes is different from the other organization. So that is why people are so much passionate about creating great products, and everyone is behind it, that how they can launch new products with new features, advanced features, to attract customers and give them good value for their money. So going to the next slide, that this is what I have already said, that why we need new products in the market. What is the need for the new product development? So it's a competition, that if you do not, or some company doesn't come out with a new product, somebody else will do. Definitely they will do. And it's a sustenance in the market. We have seen over the period of time, there are many companies, they have popped up and they have faded down in the span of 10 years, 20 years. Why? Because they did not do any innovation. They felt very complacent with their products, that their products are doing good. Kodak, for an example, those famous film company, they are very complacent, and they are very much happy that their products are selling. But they did not know that there are many other organizations that are growing up in the background. There is a undercurrent going on. So we always have to be very, very innovative. So challenges in the selling method, then the policies of the government, technology improvement, policies of the import and export. I'm just reading those things. And customer national character, gap in the market. And so these are some of those major points, that why people need new products to be imposed into the market for their own sustenance, for existence in the market. Now, this is what happens to a product. You can remember that we all used to use this telephone in 1970s. How it got obsolete. Now no, today's kids doesn't know how to operate this telephone. So it got outdated, and then came out the all famous Nokia, this phone, right? We all remember this phone, the first mobile phone. and then it also got faded, outdated, and this the smartphone came up. So every year, previously, every 1 year or 2 year or 3 years, a new product was coming up. But now, every 2 months you can see a new brand. Every 2 months you can see a new model coming up, and the customer or the companies who are not able to do that, they will be simply out of the market. And what are the things that needed to be done to stay in the competition? That is a very aggressive product development method. So why people buy new products? They need a new experience. They are bored with the old product. It simplifies a task. Whatever this phone could not do, the smartphone is doing nowadays. Convenience of use. It also enhances the self images, status symbol, life changes. So everyone needs new product. Now, this is what entire product life cycle. Initially, you can imagine, some 8 years, 10 years back, those LCD TVs or mobile phones, it used to sell in 80,000 rupees or 1 lakh rupees, because that time all the money was being imposed to for this research and development. That time, their product cost was very high, so they could not make any profit out of it. Now the entire R&D cost is gone, so now they have entered the profit cost. So that is how the product life cycle initially, whenever they are a cash flow, initially they will go for a loss, because there is a huge amount of money has gone behind the initial product development, initial research and development. After that, they will just cash money. And if you see here, over the period of time, the product fades out, and then it declines. They're just gone out of the market. And this is what happens. The customer expectation always grows that the product will be continuously improving. But normally what happens, that overall the product, the quality of the product, it declines or flatten out over the period of time. This is where we need the innovation, or that second kick or the second booster of the rocket needs to work over here, just to give them the next thrust to go to the next level with that innovation. So innovation is extremely important everywhere. Every company is going behind the innovation and new technologies, digital technologies. So product development process is, we have to first of all, till now, is there any question, Deepak sir? Am I going too fast or too slow?
Yeah, it's okay.
It's okay, sir.
Yeah, okay.
Okay. So product development process, basically, we need to first of all start with a customer viewpoint, that what is their perception about a product, what kind of improvement they want in a product. So this is a market study that needs to be done. Initial inspiring the new product visioning a new product. Then we also need to understand, if I create this product, whether it will sell in the market. So that is a business case and analysis activities. Then we also need to understand what kind of marketing efforts that we need to put behind it to sell this particular product. Then obviously the technical engineering, the design activities, that is the core of any product development, the design activities that has to come inside it. And obviously the manufacturing plan, all those things, whatever I dream, it has to be manufacturable. So those manufacturing plan, and then the product design validation and everything, it comes in. So those are the some of those granularized points for a product development. And various segments, as I said, there are various segments where products lies: aerospace, automotive, chemicals, oil and gas, customer products, telecom, semiconductor. Some of those segments that I have listed over here. Now this slide is very important, that what are the challenges of a product development, and the points, the key points for a company for a sustainability over a long period of time. So first pillar is the continuous improvement and innovation, that they have to continuously improve their existing product and innovate to create a new product. Otherwise they will fade out, and a good amount of money has to be spent in the R&D domain to stay in the business. Now, higher quality at lower cost. quality has to be absolutely 100%, and that is by default. Everybody wants quality to be absolutely default, 100% quality, but the cost also has to be, very, very competitive. So that is the second point. And the third one is that, you cannot take 2 years or 3 years to meet all those criteria. It also has to be very, very time bound. So within 6 months, a new car has to come out. So these are all some of those very, very, challenging scenarios for a company to sustain in the market. So what do you do? So these are the different pillars for a product development, that pre-development, development, and post development. Okay, so in the pre-development, we new product opportunity we find out, then idea generation happens, feasibility happens, then the project planning happens, then concept creation, design creation, modeling, testing, prototyping, and product introduction and distribution. Till now there are a lot of text I'm just reading. I have few beautiful videos coming up which will make people little interested in this. Now this slide is also very important, that it's a very favorite slide for me, that see, this rising sun casts the longest shadow. Where we need to put our maximum effort in the entire product development cycle is the first design phase. The more robust design we do in the CAD, CAE, and the more time we spend in our drawing board to finalize with iterations to make sure our design is robust, the less money we will spend in the prototyping or physical testing or field failure on all other future problems. Just like building a kid's career or his own foundations, the more time you spend with him during his initial 7 years or 10 years period, that builds his mind. So that creates a kid's future. Similarly, for a product, the initial period, the initial design stage, the drawing board and the simulation, the designs, the more time we spend over there, the more benefits we will reap in the perspective of the money, that we will be facing less challenges in the future. Our products will not fail. It will be more robust in the field. More less customer complaints will come. Okay, so this is what most important, that in the design phase we have to spend more time, and that is where CAE will come very, very handy, computer aided engineering. Okay, and this entire process is called product lifecycle management. It's kind of an entire cycle. See, I will tell you a very small example. This entire aeroplane, the any kind of Boeing jet or Airbus, it doesn't get manufactured in a single facility. One of the components there may be the fuselage or the wings. Everything comes from different locations of the world. Believe me or not, the entire wings come from Germany. The center portion getting built in somewhere in Australia. But everybody is extremely synchronized, that not even a single millimeter of difference will happen, while all the components will come back to US. Those components will get exactly fitted into this to make a big aeroplane. So that is what the product lifecycle management is all about, that it's a coordination, it's a collaboration between the different teams, allowing teams to work accurately in different locations, how to reduce effort and money for data creation. Okay, so PLM is a very, very important process in the entire product development. It's called product lifecycle management. Okay, and the historical view, that how this PLM has evolved over the period of time. 3D CAD analysis in 1995, first analysis we evolved, we did. And then digital prototyping replaces physical prototypes for planes, because you can understand, for a model, for a particular product, if we create that product, make crores, spend crores of money to create a Mercedes-Benz car, and we just crash it, or we just do some kind of a field testing, it is going to spend a lot of money. Instead of that, we create a mathematical model. You can see the here, it's a mathematical model of a Boeing aircraft. Okay, so we create a virtual model of this particular physical entity, and we can give all the loads and boundary conditions whatever we expect it has to experience from the road load data or from the outside, whenever it hits the front wall or when it gets dropped. All the loads and boundary conditions, we actually infuse them into this particular virtual model, and we can simulate that model for 100 times. There will not be any single rupee will be spent, because that virtual model is only one time it is built. So that is the beauty of this virtual validation or computer aided engineering, where we can do multiple iterations uh, before doing the actual prototyping. We will definitely do the prototyping, we will build this car, but we will not build 50 cars. Previously it used to happen, we used to build 50 cars because we never has the technology. Now we have this technology of virtual validation, where we physically we create a mathematical model and we simulate it. Now we have a central server where we have see this CAD process, CAE process, and tooling design, everything. Okay, so in the centralized database, HPC database, it's all secured: item management, product structure, engineering changes, task management. So entire thing is product lifecycle management. uh Divak sir, till now it is okay, or any question from anyone?
Oh, no question. I'll interrupt you. So far, it's good.
Sure, sir. Sure, sir. Okay. So I will take one segment here. Let me take my favorite automotive segment, and I'll just try to, try my level best to explain that, how a product development happens in an automotive. Okay. So in automotive, you can see the bottom of the pyramid is the part suppliers. Okay, that is the flattest of all, all the components that has been supplied from part tier 4 companies. Then the component suppliers, tier 3 companies. Then the system and module suppliers, the tier 1 companies, and then the OEM. They all gets, combined or assembled together. Okay, so it all starts with a beginning, a sketch, ideation. It's a sketch in the drawing board. The designers, they sketch the model, and they, with a clay model, they create this car. Okay, after that it goes straightway into the design software. That is there are a lot of design softwares like SolidWorks, CATIA, Creo. Okay, so in that they create the classes surfacing, all those, the entire car is actually given a surfacing. It's a virtual surface. Okay, so classes surfacing they make for all those, the entire car, entire model. Every system is modeled here. You can see the details, the tires, the bonnets, the front end of the car, everything is completely detailed model. Okay, so with this particular design, previously what used to happen is that they used to do some very preliminary analysis and straightway go into a prototyping, that let us build this car and let us bang it in the wall. Let us test it, what happens, whether it fails, whether it breaks. Okay, uh, but it is jumping directly into a prototype. It's not the good idea what used to happen previously, because it is going to cost huge amount of money. You can imagine creating, this is a Jaguar car. So creating a Jaguar is almost like, spending 80 lakhs to 1 crore rupees. And how many times you want to do testing, you have to spend that much of money. So instead of that, so I'll just go to a crash testing video over here. Let me see whether it is visible to all of you. Sir, is my screen visible?
Yeah, PPT is visible, not the video.
Not the video. Okay, how to stop sharing? I will again share screen. Okay. Okay. So is my screen visible now?
Yeah.
So this is a physical testing, a sledge testing of a Maruti car for the global new car assessment program. This is how the test a car with sitting all the dummies, passenger, co-passenger, and the child dummies. This is how a car is tested after they are all virtual validation and everything is done and the final prototyping is done, just to test whether our virtual validation on all the calculations whatever we have done back in the drawing board all are matching with the physical testing, because correlation is very very important. Because your virtual validation is just a mathematical model, it's a junk in junk out. Whatever junk you are going to put inside, it is going to give you some junk out. But we also need to do some kind of a testing so that we can correlate between a virtual model, mathematical model, and a physical model. So this has been done in our ARAI, Automotive Research Association of India in Pune. So this kind of a sledge testing happens in Pune. So this is an offset barrier test. You can see here, this is an offset barrier. It's not a full frontal with all the dummies, and you can see airbag deploying. So this is how the things are all tested, and these dummies, they have, these are all accelerometers or the, the points, output points. We take the head injury criterias and all the, the accelerations from the ribs and neck and abdomen, everywhere the injury has been takes out from here, and you can see all those points, the displacement and the heating criteria, everything is output from this particular test. So this is how an actual physical test happens. So this is a child dummy. You can see this is an offset barrier, right? This barrier is not full frontal. There is no, it's not a full frontal, because this is the most frequent accidents happen like this. Whenever two cars see each other, they try to deviate from each other. So that is why this offset barrier is the most frequent impact that happens in the road, and also it's most severe, because it takes only one portion of the car. So the rest, this portion is not taking any energy. All the energy is being absorbed by this particular portion. That is why it is extremely severe load case. Okay, so I'll just stop sharing here. Sir, my screen is visible.
PPT is visible.
Okay, sir. Video, you guys, you could see?
Yeah, video we could see properly.
Okay, sir. Okay, sir. So that is why, the application of FEA comes into the place. So why FEA? What is finite element analysis? Finite means, this car is an infinite space. Okay, so we need to reduce this car, we need to discretize this car or any component into some finite small elements. We need to create a meshed model, a mathematical model, and we need to apply those. See, those car is running with a velocity, so that velocity is an input, that is the loads and boundary conditions. And those dummies we actually position there inside, those dummies are also virtual dummies. And the barrier, the what is the material and everything, the steel, the material properties, the tire material properties, everything is infused into that particular mathematical model, so that a car behaves like a car, a suspension behaves like a suspension, a tire behaves like a tire, so that it's a absolute replica of a physical model into a exact equivalent mathematical model. So why we do this? Because we have to reduce time and cost. You remember those three pillars here? These three pillars: continuous improvement and innovation. We innovated something and we quickly implement that into mathematical model. See, suppose we create a virtual model and we want to do some changes, slight changes into that model. We can quickly do that because it's just a model, virtual model. But to do a change in a physical model, in an actual prototype, it is very difficult. You have to create that component, you have to create a die, you have to create a cast, you have to punch it, and you have to actually create that component and fit it into a car and again test it. So this continuous improvement or innovation is very easy through FEA, lower cost, because once you create a virtual model, you can simulate it n number of times. So cost and quality. So why reduce cost and cost of multiple prototypes? You do not need to create prototypes and increase accuracy of testing. That this is very very accurate model will create the exact correlation with the physical model. And incremental system level development process. You do one simulation, you see that there is a fault in the system, it is breaking here, it is not meeting our criteria. You might have heard there are a lot of ratings. This Tata, one Tata model is 5-star. What is 5-star? So 5-star rating is a safety rating that in those driver, passenger, child dummy, there are a lot of, I have told you that those accelerator output points, they test the injury criteria in all those chest, pelvic, back, everywhere. They test all those out, the accelerations and the injury criterias, and they give a rating that this car has sufficient energy absorption mechanism so that the dummy, the driver and the co-driver and the child passenger is not experiencing much damage. In case of crash with this much velocity, they will survive with a airbag. So that is how a 4-star, 3-star, 5-star rating comes into the place. It's a safety rating. So to reach that 5-star rating, definitely the Tata car would not have reached in a single month or 2 months or 3 months. They have incrementally reached there with lot of iterations through this mathematical model and different stages of validation. After that, they have reached into a model. They have seen that, in through validation, that my model, the injuries are below the limit. After that, they will create a prototype. By that, they would have saved almost 20-30 prototypes, almost 20 crore of almost 3-4 crores of rupees they have saved it. And they can do it in a very very quick period of time because building prototype is very difficult. So initial design and then simulation and validation. So designers and validation engineers, they talk to each other. They have to be absolutely collaborative, because designers give a design to a CA engineer validate that model, suggest the changes to the design engineer quickly incorporate that changes into the model, again gives back to the simulation engineer. So this kind of to and fro collaborative environment will generate a kind of a robust design, and then they finally go for a physical testing and prototype. So that is why we call that it's a product development powered by simulation. So finite element analysis. See this particular bracket, it has been beautifully discretized into small elements. These are all called elements. So there is a different software available to create those elements. It's called hypermesh. Many of you might have heard about it. So it's a very very popular technology. Automotive industries has been using it for the last 20 years, and extremely popular technology, this FEA technology, to create a mathematical model of a physical object and simulate it with all the reality level loads and boundary conditions, and simulate the reality that this is how this particular component will behave. Okay, so I'll just quickly go that real life objects. physics simplified physical model, that is the CAD data, and from the CAD data we discretize a meshed model and equivalent mathematical model. Not going too deep into any kind of technical details here. Okay, so this is how a car is built, a meshed into hypermesh. You can see here hypermesh. So this is how a car is built in a hypermesh environment for rest of the simulations. Okay, till now any questions from anyone?
No, it is going well.
Okay, sir. Thank you, sir. So now for FEA, for the simulations, what are the different type of very common simulations? There are n number of simulations we can actually linear static analysis, all different type of simulations we do. But very favorite simulations are very well known simulations is actually correlated with the familiar failure that we see around us, like this fatigue simulations. Fatigue simulations is what? It's a repetitive loading. When a car goes through repetitive ditches, so it's do a repetitive loading, and you can see that if you take a simple kind of a plate, a metal plate, and you do like this, it will easily break. So this is called a repetitive loading. So this repetitive loading, the failure accelerates. So we actually simulate a fatigue simulation and also try to understand what is the life of the component. There are two different type of fatigues. One is low cycle fatigue, one is high cycle fatigue. So normally in our life, what we see is a low cycle fatigue. So in that, the failure aggravates, it accelerates. In normal conditions, our component doesn't fail, nothing fails, but if it is if it is experienced in a repetitive loading, a fatigue loading, it fails easily. So we have to simulate that, and we have to restrict that. There are some YouTube videos here. My screen is visible, sir?
YouTube video is not visible.
Okay, YouTube video is not visible. So every time I have to do 1 second, sir. Fatigue, and then share screen, fatigue. Okay, so see here, this is a repetitive loading. You can see here there is a crack will generate in between. So see, a crack is getting generated here because of this repetitive loading on the side. Otherwise, nothing would have happened to this particular bar. But because of this repetitive loading, this crack is getting generated, and finally this component will fail. If you see here, this component will fail. So this is called a fatigue loading. Okay. Similarly, there is vibration. You can see the vibrations in many instances. A tuning fork, right? It's a very common example of vibrations. It vibrates, and then engine vibrates. Engine, in any car noise, whatever noise comes into the car, powertrain or engine is the major source of vibration. So we have to reduce vibration by some dampers. You can see some rubber dampers at the bottom of the washing machine, how it creates a damping activity, so it damps down the vibration. So those are some of those activities that we do in vibration analysis. Then next come is the computational fluid dynamics. This is also a very important chapter. You can see why a plane's nose is like this. It's kind of a aerodynamic design, right? Because the air, it will allow the air to pass over the body, right? Even the car's model is also like a aerodynamic. Any sports car model, you will say it's a very aerodynamic model, right? So I'll show here one more small. So we also do CFD simulation. So this is a wind tunnel test actually. This is a wind tunnel test is being done on a particular car, a sports car, just to see how aerodynamic design they have. This is called computational fluid dynamics. There are many other CFD analysis we can do for underhood thermal. If you open the hood of the car, the engine gets very much heated. So we need to do a underhood thermal analysis. So this is a kind of a wind tunnel test for a to check the aerodynamic of a car. Okay, so now going back to the my PPT. Second one is crash. I have already shown you the crash test that happens. Okay, high speed crash impact. And the fifth one is very important. It's optimization. Optimization is everybody likes to make a over designed component. Anybody has any question? Okay, can I proceed?
Yeah, go ahead.
Okay, optimization. So I was talking about optimization. See, it's a any component or any product. All everybody used to make it. Everybody loves to make it a over designed product. Okay, so that it never fails. We can make it a very thick plate. The car, suppose a car, the side of the car, we can make it a very thick plated car. But it will attract a lot of cost. It will attract weight. It will reduce your fuel efficiency. So how to optimize? Have you ever seen Ducati motorcycles? The center structure, it has some holes inside. So actually, intentionally they have taken out materials from a particular, a piece of metal, so that to make it same robust, yet less, heavy. Okay, and through those particular, lines, the load paths travel. You can see that bridge, right? So I'll show you here in this document. This is Abacus topology optimization. So you can see, first of all, they have taken an entire block, a piece, and after that they are optimizing it. So optimizing it to make a bridge. So see this. This is finally the structure. It comes out like this because the entire structure, this entire material is not needed. The load is flowing through only those paths where all you need material. So that is why the software has taken out the all unnecessary materials and kept it wherever it is only necessary. So that is how our optimization analysis is very important. So hope I am able to explain it properly.
Yes.
Okay, right, sir. Thank you, sir. So now, quickly going back, process of FEI, you can see here, I have shown you some physical dummies. Now, these are all the virtual dummies you can see here. So these are all the female dummy, this is a male dummy, and it's a case of a side impact.
Your PPT is not visible.
Oh, sorry, sir. Sorry, sir. Is it visible now, sir?
Yeah.
Okay. Sorry for that. So I have shown you the physical dummies in that Maruti Suzuki crash test. Now these are all the same virtual dummy. It has the same criteria, they have created even up to the bones, flesh, blood, everything they can simulate in these dummies. The injury on the head, injury on the ribs, pelvic region, knee region, toe region, everything they can simulate because they have accelerators over there. So these are the dummies are sold in crores, very very costly dummies, and we place these dummies in a car. This is a model of a car. We place this dummy with a side impact analysis, and we analyze that how safe the car is. Okay. Now I'll I think with this the FEA's contribution into a product development, hope it is clear to everyone that how we can reduce the entire time to the market, and we can assist the designers to design the product better before creating a prototype, by creating a mathematical model and doing multiple iterations for a better accuracy. Hope this is clear to all.
Yeah, it's clear. Very good. Very nicely covered.
Right, sir. So I will just, if I have another 5 minutes of time to cover, I think it is already 7:25, and I'll just go to the couple of advanced technologies that people are adopting nowadays. You guys might have definitely heard about it. It is called additive manufacturing and or 3D printing. So additive manufacturing is that multiple components are being, previously we used to have, you see this the plain blade right here. So this plain blade previously used to have 1000 components, and it has welds, bolts, nuts, everything inside it, and any bolt, nut, hole, anything, those are all the stress initiators. From there it will crack. So now what they're doing is that the entire blade they are manufacturing as a single piece through a 3D printing technology. So, okay, you can see this G engine over aerospace engine. It's all 3D printing technology. So any kind of complex geometry, they will do it through 3D printing. So this is one great example of advanced manufacturing that they are adopting it very very frequently nowadays. Okay, I have one more very small sweet video. Sir, my screen sharing is visible. Hello.
Yeah, yeah.
Hello.
What do NASA, McLaren, and the restaurant Sushi Singularity have in common? They have all incorporated 3D printing or additive manufacturing into their work in some form or another. 3D
Sir, you can hear the sound.
Yeah, yeah.
Okay, sir. Okay, sir. Okay, sir.
printing is bringing many changes to a number of important industries. Companies have begun printing everything from fully functioning cars to Michelin-starred dinners. Medical research institutions have even experimented with printing functioning body parts, paralleling some of our favorite science fiction shows. Recently, additive manufacturing showcased its practical versatility, becoming a powerful tool in tackling some of the unprecedented challenges posed by COVID-19, helping to supply health workers with personal protective equipment and patients with ventilators. So is the 3D printing revolution here to stay, or is it merely a trend? For the uninitiated, 3D printing is the process of making solid three-dimensional objects from a digital file, also called additive manufacturing. 3D printing centers around layering materials like plastics, composites, or biomaterials to create objects that range in shape, size, rigidity, and color. Manufacturers and enthusiasts can print aluminum parts, human tissue, carbon fiber tools, thermoplastic figurines, and even dental models. There are currently 9 basic types of 3D printing, with SLA, FDM, and SLS printing being the most common. 3D printing is the opposite of more traditional subtractive manufacturing, which usually involves cutting the final object out of a piece of metal or plastic, using, for example, a milling machine. The first 3D printing technologies may
shall I let it continue, or we will?
Yeah, I think this is good enough. But
Okay,
there is one lady who has asked the question, Shivani Madam. She has sent she must be watching it on a YouTube. So the people who are on the YouTube,
sure,
they can
sir.
send the question on my mobile.
Sure,
So
sir.
she said that what is the strength of the 3D printed product as compared to the manufactured product?
Absolutely, that's a good question. See, 3D printed product, it's a kind of a one single product, and it is created out of metal. It is created out of plastic, anything. So I believe it is more robust with respect to the other, joint products. As I also told you, first of all, there are many benefits of a 3D printing. One is that it can print complex geometries that is not possible by any other manufacturing technologies. So any kind of design that you can concept of, it can be definitely designed through 3D printing, and it is also structurally it is robust, more robust than combining 2 3 components with bolts, nuts, weldings, because those areas are stress initiators and it will fail in those areas rather than a 3D printed component.
You
but
go ahead with the-
uh,
I
but
think this video you can,
I can continue, sir.
yeah, you can continue quickly. Let's see what it is.
Okay, sir.
Made their appearance in the early 1980s. They were expensive, difficult to use, and generally inaccessible to people who lack specialized training. Yet 3D printing has been a common trope in science fiction, appearing as early as the 60s in the work of Arthur C. Clarke and sporadically in Hollywood classics over the decades.
People are using 3D printing in now printing the cake also.
Pardon, sir?
Printing cake.
Printing cake,
So you can
everything.
have a cake of a small model of yours. So they take the raster image through various cameras and form a 3D model of yours and cut a cake.
True, sir. True, sir. Yeah, see, you can see this, lost bone and some of the small portion of the
Yeah, I
bone,
think this is very
everything.
difficult to manufacture otherwise.
Yeah, so it's a wonderful technology.
Even predicted the printing of
I think major question is nowadays 3D printing is very easily, you can just design something and transfer into the hardware side. But what's
Exactly.
about the profiling part? Because if you have some existence product which I want to copy without designing into CAD CAM, is it possible just with profiling? Well, earlier days we are using analog type of profile here, just put it near to the object and based on the profiling it's set and then we can with some geometrical part we are designing. So what's about the profiling? Very important part.
Good question, sir. So I'll take that question. So right now there is a technology called ferroarm. So it's called an infrared technology. So if they just roll it out, that ferro, it's a laser technology over the particular component, it will automatically capture the entire geometry of a component and it will create a CAD model. And through that CAD model, you can replicate something. So that's a ferro. It's a ferro arm. It's called a arm.
I
Arm
think
means
it's shown in
no, it's not here.
yeah.
It's ferro arm is just it's called a arm, means it's a robotic arm with a ferro probe there, and from that probe there is a laser technology, and through that, once you roll over the entire particular model, it takes out the entire image of that particular component and it captures and it throws out a kind of a CAD model, and from that CAD model you can use as an input for this 3D modeling, 3D
Okay.
printing. Yeah,
Okay. I think it's a more accurate side if you are using something laser.
Nimil Bhai, Nimil Bhai, today in a typical organization, if you look at 25, 30 years back or maybe 10 years back, they got so many forms, leave form, expenses form, everything has gone. Now, what you do is that you print whatever form you want. There is a soft copy available. Take the sign and do it. Even people now don't print also. They do online. So similarly, today we see a lot of people selling automobile components. We see a shop selling automobile components. So maybe 2 years or 3 years down the line, you will see that those shops are vanished and he is sitting with 3D printer and he'll ask you that what is the model of your car, which year, what component you want, what is the component number. He will call that component, he will print the component and give that component to you. Like
Yes, sir.
people are
Yeah, but
printing leave form and everything. Now there is no, earlier there is a store department available where we used to go and take out the part. So now those things has gone. So 3D printing is going to bring a revolution, and people will have a 3D printing at home. Today everybody see laser printer once upon a time was considered as a luxury, and today it is available at everybody's house. Only DTP and those high-end people were used to keep. So similarly, 3D printing, the cost has also gone down. So it's going to be the technology
when
of
you
tomorrow.
when you say about the 3D, first level is design something and then transfer into the hardware. But before design something, say for example, there is some problem in accident happen, and there is problem in my right first finger. Half of the finger is fractured absolutely, and doctor say we can replace with the 3D printer. So 3D printer cannot decide the design part. Neither there is any software. There's a ferro arm. Just they will put it because there is something odd even place it. I have dig in my house and found that 1,000 years old Ganpati Murti, very Pavitra Murti, and it's something unique. And I want to replicate the the same kind of Ganesh Murti. Pharaoh arm will decide. Because Pharaoh
Absolutely, sir.
you can just move it and then just transfer into the designing part. Because I have seen the 99% marketing for the 3D printer side, but what's about the source? Well, it's very easy part. One
Yes,
thing
sir.
is, second thing is about first video, oh, that's a good thing.
Yeah, yeah.
Wow. That will give the clear picture, basically.
Right, sir. Right, sir. So ferro arm, you can see here. Can I share my screen with you?
Yeah, yeah.
Yeah, please. Yes, sir.
We
Please,
are,
sir.
we are seeing your screen.
Oh, you are already
Oh,
seeing
we
the
were
screen?
seeing the screen.
Okay, okay. Sorry, sir. So you can see here, this is a very costly arm that we already also have in LNT. But see, this is a arm, ferro arm, and it's a robotic arm. And we first of all we need to place.
The Faro Quantum Arm, elevating the value and performance standards for manufacturing inspection and alignment. The Quantum Faro arm is Faro's most accurate arm ever. It is an industrial-grade metrology device designed for inspection, CAD to part analysis, and reverse engineering applications on parts and assemblies. Exceptional ergonomics.
So this lady is actually capturing the entire profile of this particular component through this ferro.
Oh,
You
So
can
it
see
is a
this.
point cloud data which basically gets into the system, and from
Yeah,
there people build the 3D model
3D
and then
model.
print it on the 3D printer.
Yeah.
That is the
So it is
technique.
through this particular probe and this arm. She is capturing the entire profile and building a CAD model.
Minimize user effort and fatigue. With the FaroBlue Laser Line Probe HD, Quantum integrates the best laser scanner available in the market.
See this. This entire model is created now.
okay.
She has actually captured the entire profile through that ferro arm. So beautifully it has, actually the entire profile has come up.
What is this color shows?
Performance bar and ensures maximum measurement consistency and reliability for every working condition. It sets a new standard for ruggedness. The Quantum offers robust Wi-Fi for wireless probing and scanning.
Oh,
Extreme portability with dual hot swappable batteries. Faro kinematic intelligent probes allow you to quickly and easily switch probes without the need to recalibrate.
is it touching the component or keeping it away?
Yeah, he is touching the component.
He's touching it.
Wherever the measurement is needed. Quick and easy setup.
What is the accuracy level?
Intuitive, user-friendly
Accuracy is very high, sir. Actually, it could be in microns.
Okay.
measuring device.
So it's a lesser, no? Basically, if lesser is there, then there's a possibility.
Return on investment. Optimize your
In
production.
Surat, specifically in diamond process, similar kind of technology used. When we receive the rough diamond from mines, They take the picture with the camera, and camera transfer that picture and decide software decide how many diamond we can adjust in this row diamond part, and then they will do the planning side with the laser.
Right,
That's a
sir.
very safely. But yes,
Right.
thinking about, sir, what you were shown earlier part, that's about the crash test. I am very happy that in India, at least we have started this kind of technology, because I think 15, 20 years back, we are not doing any crash tests. And at the same time, what you said, many people are wish that I have buy the car and I have used the 2-inch thick guard in front of my car. Looking to this crash test, if somebody using the guard, whether it's harmful or what is saving the life.
That only happens in India, sir, actually, because that guard is put to save his own car, actually, for some small impact, not for a high performance impact. Because I'll tell you, sir, the impacts are only the interior of the car is designed to absorb energies. The more energy the front portion of the car absorbs, the less energy get transmitted to the rear compartments. So that is why they make the front portion of the car more flexible to absorb energy. So if you hit a pillow, the impact will be less, right? So the pillow absorbs energy. So, and most of the cars, many cars, European cars, what they do, the interior engine is a very hard component. It doesn't crashes, it doesn't crumble. So in a case of crash, where the engine gets mounted, that mounts immediately get broken and the engine drops down. So you get more crash space inside. Okay. And the front rail, two rails where the engine mounts, it bends outward, not inward. So that if it bends outward, it creates more, space for the energy absorption. So those are all the design aspects. They create a crash initiator there. Intentionally, they create some kind of a deep initiator. You see that mineral water bottles. Those are all the initiator, crash initiators. It crumbles. ऐसा रहता है ना sir? So those are all the crash initiators. So that front portion of the car, that small bar is only for to save his car from the front. If anybody hits, his grill should not get hit actually.
Either they are saving the
Nimil
car
bhai,
because
this is exactly what happens when you are having a mobile. So when you drop the mobile, the cover opens and the battery goes out. So it reduces the weight. And I think that damage to it is intentionally designed. As you said, that engine dropped down. Yeah, sorry.
Yeah, many times, because many times when I visited Aisha and there are many automobile manufacturers, because in some of the product in career I am too early. In 1997-8, I was selling this car crash data acquisition system 64 channel. At that time, it's costing something 25-30 lakh rupees per test. In India, there are very few of the company that started to use this thing. And that's the reason that many times these automobile expert designers say, India is the so country. First, they will buy the 25 lakh rupees, 30 lakh rupees car. Straight away go to the accessories people. First, they will select the good quality of steering cover. Steering is such a design in manner today that this steering dominates you the attack thrust, it will broke down and it will save your chest. Instead of that, people are using the steering cover. Start from steering cover. Then they say never ever single screw to the front guard. Otherwise, otherwise characteristics change, and from the same area, you will it is probable to damage. There are many things. Seat cover. People are then they are seminars कि बनाने वाले गाड़ी डिजाइन करने वाले पागल नहीं है जो आपको इतना ज्यादा सीट कवर नहीं दिया. उन्होंने जो दिया है सीट कवर जो भी दिया है गाड़ी के लिए as per the design sir. I think many things I have seen in there. Now, what I understood from this is today's scenario, people are using simulation for this crash test. Earlier days, you are using the car, crash, and thus record in time, real time data acquisition, and then analysis. Now you say these are the very positive. Whatever you say, this net, some fiber net, what is software net. So that is also easily possible in mechanical area. If anyone to I would design something and I want to check the thrust, mechanical mesh if I design and just test it or
Everything.
run, the same
Everything
thing
is
is
possible,
possible.
sir. Any physical existing component, you can create a mathematical model of that, and you need to give the actual material property. Suppose it's a glass, our glass. I will give a glass property so that it behaves like a glass. If it is a plastic, I will give a plastic property. If it is steel and different grade of steel, I will give a steel property. And
Oh,
then we will also give the boundary conditions, loadings and boundary conditions, that what velocity the car is getting crashed, what kind of the load data, the load, that is coming from the road. You said that there are a lot of data. ARI also sells, ARI, Automotive Research Association of India, they have a data, a kind of a consolidated data of 7,000 kilometers road load. So that particular digital data you can actually use as an input into a software called Adams. Adams is a multi-body dynamics software. So it's a multi-physics software, multi-body dynamics. So in that, you just input that data and it will automatically simulate that car as if it is running on a 7,000 kilometer road,
oh.
right?
Right, sir. Thank you. So, what will be the age for learning all these things? If one should get the admission in mechanical engineer, then and only that. Because nowadays coding, you can see in the TV, coding is whatever level of coding, second story. But yes, India is now on such a level कि बच्चा मैटरनिटी होम से कोडिंग सीखना शुरू कर देगा. मतलब ऐसे यहाँ तक तो 5th स्टैंडर्ड तक तो हम आ गए. तो इन दिस एरिया, what are the learning age?
Sir,
Because I've noticed this CAD CAM designing, but is there any easily anybody can learn or something this? No
sir,
doubt Deepak bhai is a master, so Deepak
yes.
bhai
So
बोलेंगे आपने कभी मुझसे नहीं पूछा और फोरम में पूछ रहे हो ऐसे क्वेश्चन, तो हमारी दोस्ती पे दाव लग जाएगा. बट
सर, हमें दीपक सर से इंस्पिरेशन लेना चाहिए, दैट एट हीज एज आल्सो ही इज स्टिल लर्निंग and he is still imparting knowledge. Okay, so with lot of respect to him, there is no age for learning, sir. And this is core mechanical, and this is nothing related to any coding on. This is core mechanical, and all theory of physics goes into this. Physics,
oh,
this is all physics, Newton's laws of physics. Okay, so if somebody is good in physics and some matrix calculations, because all those whatever software it is creating, mathematical model, it's all matrix model. Okay, stiffness matrix. So stiffness matrix it is creating and it is solving into a solver. So whatever formula we read in our mechanical days, engineering days, a solver actually writes all those equations in a proper format, and then it solved that equation. So anybody can learn it master it in a few months of time. So
because
this
right now all this technology used in very high end technical part.
very high
Whatever
end technology.
when you quote the L&T तो कभी downstream के तो कोई product पे entry लेगा ही नहीं. That's confirmed. Because L&T is known for the hardcore technology. But nowadays, say for example, toy market is one of the biggest boom from the India, and this kind of technology, simulation, design, and this also the required. So, is there any possible that any person can learn the basic thing, something, not going much more in depth? Software can be learned by easily.
Software, not easily, sir. I'll tell you, there are three phases in that. There is a question from Shiba ma'am. I will take you later. Sir, I'll tell you one thing. There are three phases of this particular simulation, this particular entire virtual validation method. One is called pre-processing. Pre-processing is that once you discretize the model, or when you create those small elements or create a mesh of the entire component, that is called pre-processing. And
Oh,
then you apply the loads and boundary conditions and materials and everything. So pre-processing, there are many softwares called, Hypermesh, ANSA and everything. These are all pre-processors. It creates a mesh of the component, mesh where it is generated from the design model, the A-class surfacing, what is being made in CATIA and Creo. Okay, so A-class aesthetic surfaces, whatever they being made from that surface, we create, and it's a very robust process, very tedious process of creating mesh, because you can imagine the outer of the car is very smooth. It looks very simple, but if you go inside the car, the dashboard, the instrumental panel is extremely complex. It's a plastic part, and it has lot of ribs, variable thickness. Car outer is having a single thickness, but the car plastic components are having 3 millimeter here, ऊपर जाके 1 millimeter हो जाता है. So it's a variable thickness. So everywhere you have to capture with the minute of details. So that is a pre-processing. After the pre-processing is done, sir, then we need to, that mathematical model, we need to put it in a solver. That solver is nothing but a combination of all those physical formulas, whatever we learned in our engineering days, like strength of materials, theory of machines, machine designs. All those formulas are being put across into a particular solver. Those solvers are called abacus, ansys, nastran. These solvers take that mathematical model inside, and it solves those matrix equations, metrics, 3 by 3 matrix, 2 by 2 matrix. It solves it actually, and then it gives a output. It gives a output result, that how that particular component is behaving, where it is failing. Wherever it is failing, it shows you a red mark. Wherever it is green, it is not failing. So everything is giving it will give you output, that under that particular loading and boundary conditions, how that particular model is behaving. Okay, and you need to pre-process that in a big screen. You need to just pre-process that model, that how it is behaving, where it is crashing, where it is failing, and then from there your actual engineering, the mechanism starts, that how to improve that component, how to improve the robustness. मैं क्या design improvement करूं उसमें कि वो it should not fail, right? So that is where all the engineers are working. Say, okay, my initial design is failing, ये टिकेगा नहीं, ये 20 दिन के बाद टूट जाएगा ये लोडिंग में. But what kind of, you can imagine, right, in a petrol can there are two cross marks here, right? आपने देखा होगा ऐसे बीच में ऐसे ऐसे डीप करके रखा हुआ है. Those are all strengtheners. It strengthens. A single plate is not that that not that strong. लेकिन आप उसमें अगर embossing बना देंगे, उसके अंदर ऐसे emboss बना देंगे, तो आप उसको bend नहीं कर पाएंगे. Are you getting me? एक स्ट्रेट प्लेट के अंदर, सिंपल एग्जांपल दे रहा हूं सर, उसके अंदर अगर आप बेंड कर देंगे, बेंड मतलब एक एम्बॉस डाल देंगे, तो उसको आप बेंड नहीं कर पाएंगे इजीली. सो दोज आर ऑल द डिजाइन सजेशन, सिंपल डिजाइन सजेशंस. थिकनेस बढ़ाने से है, मटेरियल चेंज कर देते हैं, फिलेट बढ़ा देते हैं, कोई शार्प एज नहीं रखते, ऐसे नहीं रखेंगे, थोड़ा फिलेट दे देंगे ऐसे. So all those design suggestions they create, they make, and then they again simulate that model to find out with the optimized design.
Right. Yeah. Thank you. Yeah, Deepak bhai, I think there is one question, Deepak bhai. What we have discussed at 5 o'clock, that 45 minutes से कुछ नहीं होने वाला है. Just aerial view.
वही पूछा कोई एक शिवानी मैडम है. Can we have one day program for this? उसका मैसेज आया मेरे को.
प्रोजेक्ट कर रहे थे हम कि I think these subjects you can go on view. Just but
no sir, I think you had a lot of good questions, sir. I think you also have knowledge. You have been extremely humble. You also have deep knowledge. You are not opening out, sir.
सर आज इतना खुशी का दिन है मेरे लिए. 10 साल से मैं FET में आई एम जस्ट कंडक्टिंग एज अ कोऑर्डिनेटर समटाइम, राइट? Honestly speaking, being engineer, when I got opportunity to attend this kind of talks, then I say, why we are, see, generally Baroda Management Association organize maximum program based on soft skill part, everything. But what's Deepak bhai view about this program is perfect. That when we are entering into Industry 4.0, then the fundamental thing is computer. Everywhere it will computer is there, and these are designing and everything. अब वो जमाना गया जो analog profile अभी right now I have to supply one analog profile. I have to import. You will surprise. Since last 3 days, I am searching in India. Ultimately, I have to import from Japan or UK. So profiling available नहीं है. So that's an outdated technology. So these are the technology that tomorrow's future will be there for production side. आप सोचो एक ही सॉफ्टवेयर से कितना काम करोगे आप ऑटोमोबाइल यू विल एंटर एग्रो इन द मैकेनिक एनी मैकेनिकल पार्ट यू विल एंटर सो दीपक भाई प्लीज
So
chairman
thank you
sir
very much,
Thank you, sir.
Tanmayji. It was one
Thank you,
of
sir.
the best lecture we ever had, and there are a lot of people who has joined on YouTube, and you really make it simple and lucid so that people can understand it in a better way.
Promise.
And one slide which you have shown, I really liked it, that the shadow of the object
Yes, sir.
is larger. Yeah, so I really like that slide, and it talks a lot about that. And I think you made this lecture really wonderful and very interesting. And I think that
All your blessings, sir. All your blessings.
so it's basically your strength and your expertise over the subject. And I think that you justified the subject, and I think nobody can justify better than you. And I think that there is a
Sir.
popular demand that
No, sir. I'm
people want that one day program. So I don't know when we can get the time and how we can organize. We'll take up with the apex body of the Baroda Management Association to have that one day program. Shivani madam, if you are there on the YouTube, we will definitely, you should have come on the Zoom and ask a question. But anyway, you will be definitely informed when there is a program for this. And thank you all the participants, and
Thank
thank
you,
you
sir.
Tanmay for
Thank you, sir. Appreciate, sir.
accepting our invitation to deliver a talk.
Thank you,
And
sir.
Friday
Appreciate,
Evening
sir.
Talk is one of the most popular program. And next
Appreciate,
week
sir.
we are going to have on Vedic science. So this is basically the beauty of BMA. That on one front we talk about the advanced technology, and immediately we talk about something which is quite antique but still valuable. And I think that Hemang Bhai has a lot of things to say about how even design can be done. In those days, people have designed Pushpak Viman and all those things. So they also must have used some technology to do that. So probably he also has something to add. So I request all the participants to be with us next Friday evening to listen Hemang Bhai Joshi on Vedic science. And thank you very much for joining for this Friday evening talk. And over to Nimil Bhai Bakshi to say a few things about the next program coming in BM.
yeah thank you Deepak bhai BMA is line up with a bunch of the program for all the great Barodian. Just now mega competition is going on annual outstanding young manager. So there's a competition right tomorrow. It's the final day, and we have selected 9 teams for the final presentation from various industries. Key player in this area, this competition. And frankly speaking, most of the time, L&D team is participant in such a manner with the hard working and lot of practice. There's most of the time they win at least one award. That's a good thing from the L&D side. And what we heard about L&D team participation, that's a fabulous thing. Apart from this, next week we have organized one more very something different kind of program. That's for women's conference, where we have invited global speaker from various part of the country. So definitely, your all people will enjoy that women conference. All the details are available over our website. And at the same time, one more program we have announced, that's a distance learning program. If somebody is interested to learn the export import management, it's a 120 hours program every day, 2 hours, 5 days in a week. So you will get all the details about this program from our website, pmabaroda.com. And may I also suggest to take a snapshot or note it down our all the helpline numbers, whether it's the email, WhatsApp, Facebook, Twitter, or Google location or YouTube site. And yes, whatever I think you must all have received some invitation either from Deepak by me or other resource. So we have mentioned about the YouTube link. That's a permanent YouTube link. Also, I wish to say that the link about the online webinar, it's the same for all the Friday talk. So sometimes if you don't receive the link, don't worry, straight away you can log into our YouTube online BMS Studio or either in the webinar link. The same will be, or at the same time, if you want to continue to receive the same details, you can just person they will add into regular our database site. So thank you, Deepak bhai. Once again, thanks a lot. And thank you, Mr. Mukherjee,
Thank you, sir.
about your experience. मजा आया, मैनेजमेंट भी
बहुत
इसमें
मजा
सुना
आया।
और टेक्नोलॉजी भी सुना। जनरली सर ऐसे के प्रेजेंटेशन में मजा आया का मतलब होता है कि समझ में कुछ नहीं आया, सॉफ्ट स्किल में ऐसा बोला जाता है, लेकिन टेक्निकल में आज मजा इसीलिए आया कि आफ्टर लॉन्ग टाइम आई एम वन ऑफ द बेस्ट फ्रेंड मितुल भाई मेहता जस्ट कमेंटेड after a decade he has attended this kind of session. He is in something different business side. But Mitul bhai said after a decade, and same thing from me. After 20, I think 2001 or 2, I left the data acquisition product and joined into other custom measurement side. Like after 20 years, at least I am very happy, Deepak bhai, that today we have changed the entire technology platform from hardware side to simulation part. You can see in Baroda, the person is giving the talk. 25 years back, I consider I am a salesperson from Western Trade and I am the only person. But nowadays, you have expert in Baroda. And this is the beauty of the technology and technology transformation. So, sir, hope industry 4.0 में L&T का तो काफी बड़ा हाथ रहने ही वाला है. And at this moment, I must congratulate to you कि आपने तो बड़ौदा अहमदाबाद बुलेट ट्रेन प्रोजेक्ट भी स्टार्ट कर दिया है. So very happily say कि we will enjoy the bullet train part also that. Thank you, sir.
Thank you.
I just want to tell that first Atmanirbhar Top Vajra 9 is being delivered by L&T and it is being sent to the China border. So I think this is the design and developed by L&T Hazira. So it is a great contribution to the nation also.
Statue of
So
Unity, sir. क्या बोले उससे आगे?
आज ही हुआ है. This is being delivered.
Yeah, 100 is a big news. But at the same time, L&T का अगर landmark बोला जाएगा throughout globally, that is Statue of Unity. No doubt, Braja is there. But
Yes. So,
So thank you. Thank you very much.
thank you very much for being with
Thank you.
us. And with this,
Thank
I
you,
end
sir.
this session. Thank you.
Thank you very much, sir. I'm really honored, and thanks for all the good words.
In fact,
and
nobody could have justified this subject better than you. So
No,
I
sir.
think we have chosen the right speaker, and
no
you
problem.
really had done a wonderful job. Thank you very much.
Thank you, sir. Okay.
Right, sir. Thank you.